this would be a level 2 question. Here it's given that if f of n is equal to f of n minus 1 plus 2n minus 1, where n is greater than 0, and g of x is equal to 8 minus 8 into x by 8, where bracket of x denotes the fractional part of x. If f of 0 is 0, what is the value of g of f of 3 plus g of f of 33 plus g of f of 333? Two things to note. First thing, f of n is given as f of n minus 1 plus 2n minus 1, and we have f of 0 is equal to 0. Combining the two, I can state f of 1 is equal to f of 0 plus 1, which is 1. F of 2 is equal to f of 1 plus 3, which is 4. F of 3 is equal to f of 2 plus 5, which is 9, and so on. So thus I am getting, if you can see, I am getting a trend wherein f of n is actually nothing but n square. The second thing to note is that g of x has been given as 8 minus 8 into curly bracket x by 8, where curly bracket x by 8 denotes the fractional part of x. Now, the fractional part of any number when divided by 8 is nothing but the remainder when the number is divided by 8 upon 8 itself. Hence, 8 into fractional part of x by 8 is nothing but remainder when x is divided by 8. Thus, g of x can now be written as 8 minus remainder when x is divided by 8. Now, we need to find the value of g of f of 3 plus g of f of 33 plus g of f of 333. G of f of 3 is nothing but g of 3 squared, which is g of 9, which can be given as 8 minus remainder when 9 is divided by 8, which is 1, thus 8 minus 1, 7. G of f of 33 would similarly be g of 33 squared, which is 8 minus remainder when 33 squared is divided by 8. Now 33 squared is nothing but 32 plus 1. Hence 33 squared divided by 8 would just leave a remainder of 1 because 32 is divisible by 8. So thus g of f of 33 is also 7. Similarly, g of f of 333 would be 8 minus remainder 333 squared by 8, which would again be 8 minus 1, which is 7. 333 can be written as 328 plus 5. Now 328 is divisible by 8, 5 is not, but 5 square gives me 25. 25 when divided by 8 leaves a remainder 1, thus 8 minus 1, which is 7. Hence when I add g of f of 3, g of f of 33 and g of f of 333, I get 7 plus 7 plus 7, which is 21.